Here we have been asked to find the order of the acidity for the following compounds. Now what we observe is that two of these compounds are going to be carboxylic acid. One compound is an alcohol. The general observation is that the acidity of a carboxylic acid is always higher than the acidity of alcohol. But we must exactly understand the reason for this. And also what we must understand is that the concept involved here says that higher the acidity of a compound, more easily it will release a hydrogen ion or an H plus ion in a solution, and the part that is left behind or the anion that is formed, it is called the conjugate base of that acid. And higher the stability of the conjugate base, higher the acidity of the compound. So the acidic hydrogen from all these three compounds is released in solution and the conjugate base or the anion is left behind. Now in compound 1 what we observe is that when we make the diagram of the conjugate base, what we understand is that the negative charge resides on an oxygen atom, but it is in resonance with the carbon oxygen double bond. This offers added stability to the conjugate base. In the second compound, we observe the same thing, that the negative charge resides on an oxygen atom, but it enters resonance with the carbon oxygen double bond, adding extra stability. But in the third compound, what we observe is that there is no resonance here. Thus, acidic strength of compounds 1 and 2 is more than that of compound 3, as the conjugate bases that are formed, conjugate base of compounds 1 and 2 is more stable than the conjugate base for compound 3. Thus, in the following compounds, compound 3 is going to have the lowest acidity. Now what we understand is that the difference between the conjugate bases formed for compound 1 and compound 2 is that compound 2 is having a chlorine atom bonded to a carbon atom in the parent chain, and chlorine or any halogen atom is a minus I group. It is going to attract electrons towards itself. It is going to attract a negative charge towards itself. Thus, it will offer added stability to the anion. Thus, what we can say is that it will increase the stability, and when it increases the stability, it will increase the acidity of the compound. When the stability of the conjugate base is increased, the acidity of the compound will also be increased. Thus, what we are able to say is that the acidity of the compound 2 is more than the acidity of compound 1, which is more than the acidity of compound 3. Thus, when you look at the available options, the correct option is option C.